Hi, this video is a continuation of the last one. In this one, we're going to try to discuss how you can best understand the unit circle using radians. So in the last video, we talked about degrees. Now, what's going to make radians different? So what you can see here, I've redrawn the kind of unit circle we had in the last video. It might be a little weird to look at, but just start by remembering that these light blue or cerulean lines are what we call quadrantals. And then the rest of the lines are colored basically how close are they to the x-axis. So the green lines are always the closest to the x-axis. The red ones are a little bit further away. And the purplish color lines are the furthest away from the x-axis. So let's first start by doing the quadrantals because these are always the easiest and you should really memorize these. Good way to do it. So first is 0. Positive x-axis is always where we start our labeling from. Next would be pi over 2. So a lot of people always ask, why is that pi over 2? That doesn't make a ton of sense. It's off the screen. And the reason is, if you look back to conversions between radians and degrees, you know that 90 degrees is a right angle, which going from the positive x-axis to the positive y-axis is. If you convert from 90 degrees to radians, you get pi over 2. Pi would be over here. 3 pi over 2 would be over here, and 2 pi would be over here. So those are definitely worth memorizing. As far as what's left, here's the best way to think about it. Basically, any one of these green lines is going to have a denominator over 6. For now, just kind of accept that. I'll show you how that works out a little bit later. So anything that's the closest to the x-axis will be over 6. I'm going to go over this. All of these ones that are close to the x-axis are going to be something times pi over 6. All of the ones that are in the middle are going to be over 4. So this is going to be over 4. This is going to be over 4. This is going to be over 4. And this is going to be over 4. And all the ones that are closest to the y-axis or furthest from the x-axis are going to be over 3. Okay, so now that we've looked at these, I see all of these are over what they are. And I hope that is clear to you, that the ones that are closest to the x-axis, the ones that are closest to that horizontal line cutting through the middle, so that would be the line that is in between this line and this line, are over 6. And as you get further away from that line, they go to over 4 and then over 3. Okay. So in the first quadrant, it's just what those numbers are. It's just pi over 6, it's just pi over 4, it's just pi over 3. As you go into the other quadrants, the way to figure it out is you basically start counting up. So I'm going to do all of the pi over 6's at first. So within the first quadrant, this is 1 pi over 6. Okay, good. We knew that. Now as we go to the second one, we need something that's over 6 and doesn't reduce. So what I'm going to do is I'm going to think of different integer values that I could put in here. I might try 2 pi over 6, but no, that reduces to pi over 3. 3 pi over 6, no, that reduces to pi over 2. 4 pi over 6 reduces to 2 pi over 3. And 5 pi over 6, now that doesn't reduce, so that's how I know this is going to be 5. I go to the next one that's pi over 6, so this one over here, and I think, okay, I'm up to 5. I'm going to count again. So 6 pi over 6, no, that reduces. 7 pi over 6, that doesn't reduce, so that's going to be a 7. And then I'm going to go to the next pi over 6. I'm going to do the same thing. Well, 8 pi over 6, that reduces. 9 pi over 6, that reduces. 10 pi over 6 reduces. But 11 pi over 6, you can't reduce that fraction. 11 over 6 cannot be reduced any further. So I hope that makes sense. If it does, go ahead and pause the video and see if you can try to use that reasoning to guess what's coming next. If you're still not sure, I'll go ahead and go through them. So the pi over 4 is, well, when we know this is 1 pi over 4, and you don't have to write the ones for any of those. I'm just doing it to demonstrate and illustrate a purpose here. All right, so after 1, what's next? Well, we're going to look at this one over here. 2 pi over 4, well, that would reduce. 3 pi over 4 would not reduce. So that's going to be that. Going on to the next one, 4 pi over 4, well, that reduces, but 5 pi over 4 doesn't. As I go to the next one, 6 pi over 4 reduces, but 7 pi over 4 does not. Next, I'm going to look at the pi's over 3's. Well, again, in the first quadrant, it's always 1. In the second quadrant, well, 2 pi over 3, you can't reduce that, so it's just going to be 2. Going to the next quadrant, 3 pi over 3 doesn't or does reduce, I'm sorry, that reduces to just pi, before pi over 3 does not, and 5 pi over 3 does not. And this is, from what I found in talking to students, really one of the best ways to think about the unit circle. So just to recap really quickly, I first drew the quadrantals, and then labeled them. So the quadrantals are the axes. So these ones right here would represent quadrantals. That one, that one, that one, and that one. Really, the best way to memorize these quadrantals is to memorize them. But another way to think about it is to say, okay, well, it's a 90-degree angle between this one and this one. So therefore, if I were to convert 90 degrees to radians, it would be pi over 2, and you could do that all the way around if you chose. But definitely much, much better to think in terms of radians. Next, I looked at these lines and I recognized that the ones closest to the x-axis should all be over 6. So like that was over 6, that was over 6, that was over 6, and that was over 6. The ones a little bit further in are all over 4, and the ones further than that are over 3. I then, basically starting from quadrant 1, just count up until I find numbers that don't reduce. I plug that number in, and then I go to the next one. So I start with over 6, 1 pi over 6, that's good. Find that 2 through 4 all reduce. So the next pi over 6 has to be 5 pi over 6, 7 pi over 6, and 11 pi over 6. And I just continue that essentially all the way around the unit circle. So I find this to be much easier, where I just have to memorize that, certain things are over 6, over 4, and over 3. I consider that 3 concepts. And then this counting method, I consider 1. So I see this as memorizing 4 things as opposed to memorizing all these things on the unit circle. So I hope you found that helpful.